Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the value of line segment X that is inside rectangle ABCD, and in the second question, we will find out the value of the green shape that is inside a semicircle. So we start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have this circle, and we know that the tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle is equal to 85 units in its length. The tangent from point C to this circle is unknown. The length of the tangent from point C to this circle is unknown, so it is equal to x, and we have to find out the value of x. And finally, the tangent from point D to this circle is equal to 35 units in its length. And as I already mentioned, our mission is to find out the length of the tangent from point C to this circle. That is to say, to find out the length of x. So first of all, we will define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as E. We will define the point of tendency of the tangent from point B to this circle as F. We will define the point of tendency of the tangent from point C to this circle as T. And finally, we will define the point of tendency of the tangent from point D to this circle as M. In the next step, we will join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of the circle that we will define as R. We have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. We have the radius OM that is drawn to the point of tendency, therefore according to this rule number 1, tangent AB will be perpendicular to the radius MO. So if tangent AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle is also equal to 90 degrees according to this rule number 1. So we actually can implement rule number 1 in our drawing. Why? Because in our drawing we have the radius OE that is drawn to the point of tendency, and therefore according to rule number 1, tangent AE will be perpendicular to the radius AO. That is to say, this angle will be equal to 90 degrees according to rule number 1. Likewise, we join points O and E. We'll join points O and M together by a straight line. Again, point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle that is equal to R. And again, we have the radius OM that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. So here, point O is the center of the circle, point F is the point of the circle itself. Therefore, OF is the radius of this circle, and we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. And finally, we'll join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle that is equal to R, and we have the radius OT that is 1 to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. In the next step, we join points O and A together by a straight line. By joining points O and A, we actually created the right triangle OAE. We will implement the Pythagoras theorem on the right green triangle, triangle AOE. According to the Pythagoras theorem, in the right green triangle, triangle AOE, where PT is abbreviation for Pythagoras theorem, so in the right green triangle, triangle AOE, where PT according to the Pythagoras theorem, the square of the equators equals to the sum of the squares of the perpendiculars, that is to say, AO square will be equal to OE square plus AE square. Repeat again, according to the Pythagoras theorem, in the right green triangle, triangle AOE, AO square equals to OE square plus AE square. So, AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given as the question, therefore AE square is 33 square. So, in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we join points O and B together by a straight line. And we implement the Pythagoras theorem on the right yellow triangle, triangle OFB. On the right yellow triangle, triangle OFB, according to the Pythagoras theorem, by PT PO square equals to OF square plus FB square. I repeat again, in the right yellow triangle OFB, according to the Pythagoras theorem, BO square equals to OF square plus FB square. So BO square equals to OF square. OF is R, therefore OF square is R square plus FB square. FB equals to 85 units according to what is given as the question, therefore FB square is 85 square. In conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. In the next step, we'll join points O and C together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle, triangle OTC. The right orange triangle OTC by PT CO square equals to OT square plus TC square. Repeat again, in the right orange triangle OTC, according to the Pythagoras theorem, CO square equals to OT square plus TC square. So CO square equals to OT square. OT equals to R, therefore OT square is R square plus TC square. TC equals to X unit, therefore TC square will be equal to X square. So actually in conclusion we found out that according to equation number 3, CO square equals to R square plus X square. And finally, we join points D and O together by a straight line. And we implement the Pythagoras theorem in the right pink triangle, triangle DMO. In the right pink triangle, triangle DMO by PT DO square equals to MO square plus DM square. Repeat again, in the right pink triangle DMO, according to the Pythagoras theorem, DO square equals to MO square plus DM square. So DO square equals to MO square. MO equals to R, therefore MO square is R square plus dm square. dm equals to 35 units according to what is given as the question, therefore dm square is 35 square. So, in conclusion, we found out that according to equation number 4, dO square equals to R square plus 35 square. So in the next step, I will copy the 4 equations that we derived from the Pythagoras theorem in a new page. According to equation number 1, we found out that AO square equals to R square plus 35 square, R square plus 33 square. According to equation number 2, found out that BO square equals to R square plus 85 square. According to equation number 3, we found out that CO square equals to R square plus X square. And finally, according to equation number 4, we found out that DO square equals to R square plus 35 square. In the next step, I will copy rectangle ABCD with its circle inside it, and we'll analyze the rectangle with its circle. So actually this is rectangle ABCD that I copied from the original drawing. Inside rectangle ABCD, we have this circle. The center of this circle is at point O. We know that all the angles inside the rectangle are right angles, so all those four angles are right angles. That is to say, this angle equals to 90 degrees. This angle, it is also equals to 90 degrees. This angle equals to 90 degrees. And finally, this angle equals to 90 degrees. From the center of this circle, that is to say, from point O, we will draw perpendicular on AB. Again, from point O, we will draw perpendicular on AB. And then we will extend the perpendicular towards DC. Okay, so actually, this angle equals to 90 degrees, and this angle will be equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from point O and AB as T. Because of the fact that side AB in rectangle ABCD is parallel to side DC, it means that the perpendicular from point O to AB must be also perpendicular to DC. That is to say, this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees. We define the touching point of the perpendicular from point O and DC as point M. Likewise, from point O, we will go perpendicular to BC. Again, from point O, we will go perpendicular on BC. And then we will extend the perpendicular from point O towards AD. So here, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as point N. Because of the fact that side BC is parallel to side AD in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point of the perpendicular from point O and AD as point H. So inside quadrilateral AT edge O, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 300. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be also equal to 90 degrees. Why? Because 90 degrees plus 270 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So, inside quadrilateral ATHO, we have 4 right angles. Therefore, quadrilateral ATHO is a rectangle. Likewise, in quadrilateral HODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. And therefore quadrilateral HODM is a rectangle. Likewise, in quadrilateral TBON, we have 1, 2, 3 rectangles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrilateral TBON is a rectangle. Likewise, in quadrilateral ONMC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrilateral ONMC is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. We will define side A edge as edge 1. We will define side HD as edge 2. We will define side AT as B1. And finally, we will define side TB as B2. We also know that the opposite sides of a rectangle are equal to each other. That is to say, side AT must be equal to side edge O in rectangle AT edge O. But we know that side AT equals to B1, therefore side edge O must be also equal to B1. Likewise, A edge must be equal to TO in rectangle AT edge O, but we know that A edge equals to edge 1, therefore TO must be also equal to edge 1. In rectangle edge ODM, edge O must be equal to DM, but we know that edge O equals to B1, therefore DM must be also equal to B1. And edge D must be also equal to OM in rectangle edge ODM, but we know that HD equals to H2, therefore OM must be also equal to H2. In rectangle TBON, side TB must be equal to side ON, but we know that side TB equals to B2, therefore side ON must be also equal to B2. TO must be equal to BN, but we know that TO equals to edge 1, therefore BN must be also equal to edge 1. And finally, here we have in rectangle ONMC, side ON must be equal to side NC according to the rule that the opposite sides of the rectangle are equal to each other. But we know that side OM equals to H2, therefore side NC must be also equal to H2. And finally, side ON must be equal to side MC in rectangle ONMC. But we know that side ON equals to B2, therefore side MC must be also equal to B2. In the next step, we will join points A and O together by a straight line. And we'll implement the Pythagoras theorem on the right green triangle ATO. On the right green triangle ATO, according to the Pythagoras theorem, we will get that AO square equals to B1 square plus H1 square. Repeat again, in the right green triangle ATO, AO square equals to B1 square plus H1 square. We will join points B and O together by a straight line. And we will implement the Pythagoras theorem in the right yellow triangle TOB. In the right yellow triangle TOB, according to the Pythagoras theorem, we will get that BO square equals to B2 square plus H1 square. I'll repeat again, in the right yellow triangle T or B, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. In the next step, we join points O and C together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle, triangle O and C. On the right orange triangle, triangle O and C, according to the Pythagoras theorem, we'll get that CO square equals to B2 square plus H2 square. Repeat again, in the right orange triangle O and C, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square, and finally we'll join points D and O together by a straight line. And we'll implement the Pythagoras theorem on the right pink triangle, triangle HDO. According to the Pythagoras theorem, on the right pink triangle, triangle HDO, DO square equals to B1 square plus H2 square. Repeat again. In the right pink triangle HDO, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. So here we have two different equations for AO square, we have two different equations for BO square, we have two different equations for CO square, and we have also two different equations for DO square. So in the next step, we'll create four more equations. According to equation number 1, AO square according to the first expression must be equal to AO square according to the second expression. So AO square according to the first expression is R square plus 33 square, and it must be equal to AO square according to the second expression, that is actually B1 square plus H1 square. In conclusion, conclude that according to equation number 1, R square plus 33 square equals to B1 square plus H1 square. Likewise, we create equation number 2 that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. So BO square according to this equation, equation number 2 is equal to R square plus 85 square, and it must be equal to b all square according to this equation, equation number 2, that is actually equals to b2 square plus h1 square. So in conclusion, according to equation number 2, we found out that r square plus 85 square equals to b2 square plus h1 square. Likewise, we create equation number 3 that states that c all square according to this equation, equation number 1, must be equal to c all square according to this equation, equation number 2. So c all square according to this equation, equation number 1, is r square plus x square, and it must be equal to c all square according to this equation, equation number 2, that is equal to b2 square plus h2 square. In conclusion, according to equation number 3, we found out that r square plus x square equals to b2 square plus h2 square. And finally, we'll create equation number 4 that states that d all square according to this equation, equation number 1, must be equal to d all square according to this equation, equation number 2. So d all square according to equation number 1 equals to r square plus 35 square, and it must be equal to b all square according to this equation, equation number 2, that is equal to b1 square plus h2 square. So in conclusion, we found out that according to equation number 4, r square plus 35 square equals to b1 square plus h2 square. So we have here 4 new equations, and in the next step we subtract equation number 1 from equation number 2. That is to say, 2 minus 1. So in this side of equation number 2 we have, so this will be equation number 5. In this side of equation number 2 we have r square plus 85 square minus equation number 1, we have in this side of equation number 1, so it is minus r square plus 33 square. Then we subtract this side of equation number 2 from this side of equation number 1. In this side of equation number 2 we have b2 square plus h1 square. Also equation number 1, it is minus b1 square plus h1 square. In the next step, we'll open the brackets of this equation, equation number 5, and we get that according to equation number 5, r square plus 85 square minus r square minus 33 square equals to b2 square plus h1 square minus b1 square minus h1 square. So in this side of equation number 5 we have r square minus r square, that is 0. So r square will get cancelled. In the other side of equation number 5 we have h1 square minus h1 square is 0, so h1 square will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left is actually in this side of equation number 5 we left only with 85 square minus 33 square. On the other side of equation number 5 we have left only with b2 square minus b1 square. In conclusion, we found out that according to equation number 5, 85 square minus 33 square equals to b2 square minus b1 square. In the next step, we will subtract equation number 3 from equation number 4. So it is 4 minus 3. 4 minus 3. In this way, we create equation number 6. So, in this side of equation number 4, we have r squared plus 35 squared minus equation number 3. In this side of equation number 3, we have, so it is minus r squared plus x squared. Then we move to the other side of equation number 4. We have, in the other side of equation number 4, we have b1 squared plus h2 squared minus the other side of equation number 3, so it is minus b2 squared plus h2 squared. In the next step, we'll open the brackets of this equation number 6, and we'll get that according to equation number 6, we have r squared plus 35 squared minus r squared minus x squared, that is equal to b1 squared plus h2 squared minus b2 squared minus h2 squared. So in this side of equation number 6, we have r squared minus r squared, that is 0, so r squared will get cancelled. In the other side of equation number 6, we have h2 squared minus h2 squared, that is also 0, so h2 squared will also get cancelled. So what is left of equation number 6 after we cancel those two expressions? In this side of equation number 6, we left only with 35 squared minus x squared, that is equal to b1 squared minus b2 squared. In the next step, we will multiply this equation number 6 by minus 1, and we'll get that according to this equation number 6, minus x squared times minus 1 is plus x squared. 35 squared times minus 1 is minus 35 squared. That is equal to minus b2 squared times minus 1 is plus b2 squared. And b1 squared times minus 1 is minus b1 squared. So, in conclusion, we found out that according to equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared, while according to equation number 5, we have already found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we will create the equation number 7 that states that b2 squared minus b1 squared according to this equation number 5, must be equal to b2 squared minus b1 squared according to this equation number 6. Okay, so repeat again. According to equation number 7, b2 squared minus b1 squared according to this equation number 5 equals to 85 squared minus 33 squared. and it must be equal to b2 square minus b1 square according to this equation number 6, that is equal to x square minus 35 square. In conclusion, we found out that according to this equation number 7, 85 square minus 33 square equals to x square minus 35 square. In the next step, we will add to this equation number 7, 35 square. And we'll get that according to equation number 7, 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225 plus 35 square is 1,225 minus 33 square is 1,089, that is equal to x square. So here 7,225 plus 1,225 equals to 8,450 minus 1,089 equals to x square, and 8,450 minus 1,089 equals to 7,361, that is equal to x square. So according to equation number 7, we found out that x square equals to 7,361. Here we'll take a root out of this equation number 7, and we'll get that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the positive square root of 7,361 and the negative square root of 7,361. But because of the fact that ax is the length, x is a length, so ax as a length, it must be a positive number, so we'll take into account only the positive solution. That is to say, x will be equal to the positive square root of 7,361, that is to say it is equal to 85.796 units. So the answer to the question is that the value of line segment x is equal to 85.796 units. Okay, so we finished with the first question. In the next step, I will present to you the second question. I repeat again here. The value of this line segment TC that is equal to x is equal to 85.796 units. So in the next step, I will present to you the second question, and we will solve the second question in two different methods. In the drawing, we have a semicircle. We know that AB, that is the diameter of this semicircle, equals to 6 units in its length. We also know that this angle BAC equals to 30 degrees in its size. And our mission is to find out the area of the green shape. Okay, so first of all, we will define the center of this semicircle as O. the diameter of this semicircle is equal to 6 units, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3. So the radius AO equals to 3 units, and the radius OB equals to 3 units. In the next step, we will join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself. This is exactly the definition of a radius. That is to say, CO is the radius of the semicircle, that is equal to 3 units. So in triangle AOC, AO equals to 3 units, OC equals to 3 units. So they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees according to what is given as the equation. Therefore, this angle must be also equal to 30 degrees. So in triangle AOC, 30 degrees plus 30 degrees is 60 degrees. So the missing angle here must be equal to 120 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, that is the sum of the angles in any triangle, the missing angle must be equal to 120 degrees. Okay, so in the next step, I will present to you the formula for a sector. Sector is part of a circle. So if we have here sector AOB, that could be any sector. This is sector OAB. First of all, the sign for a sector is the rounded side, the rounded line that is above O and B. This is the sign of sector AOB. And the area of this sector, sector OAB, will be equal to pi r square. It is actually the area of the circle that contains the sector. R is the radius of the circle that contains sector AOB. Here OA equals to R, OB equals to R. Again, R is the radius of the sector, the radius of the circle that contains the sector. In our case, R equals to 3 units. It is the radius of the semicircle. So it could be the radius of the circle or the semicircle that contains the sector, and you have to multiply it by theta over 360 degrees. So here AO and OB are both the radii of the circle or semicircle that contains the sector, sector AOB, and here angle theta is the angle between the legs of sector AOB. So AO and OB are also defined as the legs of sector AOB. Both the radii of the circle that contains the sector, the circle or semicircle that contains the sector, and they are also defined as the legs of sector AOB, and theta is the angle between the legs of sector AOB. Okay, so here this ratio theta over 360 degrees gives us the relative percentage that this sector occupy out of the area of the entire circle, and when you will multiply this percentage by the area of the entire circle, you will get, that is to say pi r squared, you will get exactly the area of this sector. So the relative percentage that this sector occupy out of the area of the entire circle is theta over 360 degrees, and when we will multiply this relative percentage by the area of the entire circle, that is pi r squared, you will get exactly the area of this sector, sector AOB. Okay, so the area of sector AOB equals to pi r squared times theta over 360 degrees. In the next step, we will use the new formula in order to find out the area of sector AOC. So I'll copy sector AOC in the new page and we'll use the new formula in order to find out the area of this sector. So this is sector AOC. That I copied from the original drawing. AO equals to 3 units, OC also equals to 3 units. They are both the radii of the semicircle that contains the sector. AO and OC are also defined as the legs of sector AOC. The angle between the legs of sector AOC equals to 120 degrees, that is to say theta equals to 120 degrees. So according to the new formula, the area of this sector, sector AOC, will be equal to pi r squared. R is 3 units, the radius of this semicircle that contains sector AOC is 3 units. If r is 3, then pi r squared will be equal to pi 3 squared. Theta is the angle between the legs of sector AOC, that is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total, this whole expression equals to 9 pi over 3 square units. 9 over 3 is 3. So in total, this expression equals to 3 pi. In conclusion, we found out that the area of this sector, sector AOC, is equal to 3 pi square units. Okay. In the next step, I present to you how to find out the area of any triangle by a new formula, and we'll use the new formula in order to find out the area of this triangle, triangle AOC. Okay, so here we have triangle ABC that could be any triangle. This is actually triangle ABC. We actually know that the length of side AB of triangle ABC is equal to A units. This is triangle ABC that could be any triangle. side AC equals to B units in its length, and the angle between side AB and side AC is theta, then actually according to the new formula for the area of triangle ABC that could be any triangle, we get that the area of this triangle ABC, is equal to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC that could be any triangle, it is equal to A times B times sinus theta over 2. We'll use the new formula in order to find out the area of this triangle AOC. So I copy triangle AOC in this new page, and we use the new formula to find out the area of this triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. AO equals to 4 units, OC equals to 4 units, and the angle between AO and OC is 120 degrees. According to the new formula, the area of this triangle AOC, will be equal to AO times OC times sinus 120 degrees over 2. That is to say, AO equals to 3 units, OC also equals to 3 units, sinus 120 degrees equals to square root of 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have in total 9 times square root of 3 over 2 is 4. So in conclusion, we found out that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units, and we have already found out that the area of sector AOC is equal to 3 pi square units. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of the green shape is equal to the area of sector AOC minus the area of triangle AOC. Repeat again, the area of the green shape according to the first method equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. Actually, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, the area of this green shape equals to 5.53 square units. We finished with the first method, and in the next step I present to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. I'll repeat again. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. So it is pi r squared, that is the area of the circle, over 2. Okay, so the area of the semicircle equals to pi r squared over 2. R is equal to 3 units. So therefore this expression in total equals to pi times 3 squared over 2. 3 squared is 9, so in total this expression equals to 9 pi over 2. So actually found out that the area of the semicircle equals to 9 pi over 2 square units. And we have already found out that the area of triangle AOC is equal to 9 times 4 to 3 over 4 square units. So the only thing that is left to do in order to find out the area of the green shape according to the second method is to find out the area of sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. This angle. We know that AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. So actually, the missing angle here must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, the missing angle must be equal to 60 degrees. Okay, so I will copy sector COB in a new page and we will find out the area of this sector COB according to the new formula. So actually, this is sector COB, that I call it from the original drawing. CO and OB, they are both the radii of the semicircle that contains the sector, as you can see here. And CO and OB that are equal to 3 units. They are also defined as the legs of sector COB, and the angle between the legs of sector COB theta equals to 60 degrees. We have already found out that the area of any sector is equal to pi r squared times theta over 360 degrees. R is the radius of the circle or semicircle that contains the sector, and theta is the angle between the legs of the sector. Here R equals to 3, so the area of sector C or B according to the new formula will be equal to pi r squared is pi 3 squared. Theta is the angle between the legs of the sector, that is to say it is equal to 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6, so in total this whole expression equals to 9 pi over 6 per units. Here we'll divide both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So in total we found out that the area of sector C or B equals to 3 pi over 2 square units. Okay, now we can find out the area of the green shape according to the second method. I remind to you that the area of the green shape according to the second method, it is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COC, the area of sector COB equals to 3 pi over 2 square units. So here we have 9 pi over 2 minus 3 pi over 2 is equal to 6 pi over 2 minus 9 times square root of 3 over 4. Here 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4 square units. So I found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. We finished with the second method and also with the second question. In the next step I will summarize the lecture. I will start with the first question, of course. drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. You know that the tangent from point A to the circle equals to 30 units in its length. The tangent from point B to the circle equals to the tangent from point B to the circle equals to 85 units in its length. The tangent from point C to this circle is unknown. That is the tangent that we are looking for. That is to say, we are looking for tangent CT is equal to x. So we have to find out the value of x. And finally, the tangent from point D to this circle equals to 35 units in its length. Again, our mission is to find out the length of line segment CT that is equal to x. So first of all, we define the center of the circle as O. So here we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, the circle equals to 90 degrees. We have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, the circle equals to 90 degrees. And we have the radius OT that is drawn to the point of tendency. Therefore, according to rule number 1, the circle equals to 90 degrees. And finally, we have the radius OF that is drawn to the point of tendency. Therefore, according to rule number 1, the circle equals to 90 degrees. Then we joined points A and E together by a straight line. In this way, we created, actually created the green right triangle AOE. In the green right triangle AOE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to EO square plus AO square. AO square, here AO square, the square of the hypotenuse, equals to OE square plus AE square. Repeat again. In the right green triangle AOE, AO square equals to OE square plus AE square. Okay, so here OE equals to R, AE equals to 33. Therefore, according to the first equation, AO square equals to OE square. OE is R, so OE square is R square plus AE square. AE is 33, therefore AE square is 33. So in conclusion, according to equation number 1, AO square equals to R square plus 33 square. Then we joined points O and B together by a straight line. We implemented the Pythagoras theorem on the right yellow triangle OFB. According to the Pythagoras theorem, OB square equals to OF square plus BF square. Again, according to the Pythagoras theorem on the right yellow triangle OFB, BO square equals to OF square plus FB square. OF equals to R, BF equals to 85, therefore according to equation number 2, BO square equals to OF square. OF is R, so OF square is R square plus FB square. FB is 85, therefore FB square is 85 square. So in conclusion, according to equation number 2, we found out that BO square equals to R square plus 85 square. Then we joined points C and O together by a straight line. In this way, we created the orange right triangle, triangle OTC. According to the Pythagoras theorem, CO square equals to OT square plus TC square. Again, in the right orange triangle, according to the Pythagoras theorem, CO square equals to OT square plus TC square. OT equals to R and TC equals to X. Therefore, according to equation number 3, CO square equals to OT square. OT is R, so OT square is R square plus TC square. TC is X, so TC square is X square. So in conclusion, according to equation number 3, we found out that CO square equals to R square plus X square. And finally, we joined points D and O together by a straight line. In this way, we created the orange-pink triangle MOD. According to the Pythagoras theorem, DO square equals to MD square plus DO square equals to MO square plus MD square. In the right pink triangle OMD, DO square equals to MO square plus DM square. MO equals to R, MD equals to 35. Therefore, d all square equals to mo square. Mo is r, so mo square is r square plus dm square. Dm is 35, therefore dm square is 35 square. So in conclusion, according to equation number 4, we found out that d all square equals to r square plus 35 square. Then I copied the 4 equations that we derived from Pythagoras theorem in a new page here, and those are the 4 equations that we derived from Pythagoras theorem. Then I copied rectangle ABCD with its circle inside it, and analyzed the rectangle with its circle. This is rectangle ABCD that I copied from the original drawing. This is the circle that is inside it. We know that all the angles inside the rectangle are right angles, so those 2 angles are all right angles, those 4 angles. And the center of the circle is at point O. So from the center of the circle, that is to say from point O, we draw perpendicular on AB. From point O, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. Then we extended the perpendicular from point O towards DC. Okay, so because of the fact that side AB in rectangle ABCD is parallel to side DC, it means that the perpendicular to AB must be also perpendicular to DC. I repeat again, because of the fact that side AB in rectangle ABCD is parallel to side DC, the perpendicular to BC from point O must be also perpendicular to DC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Then from point O, we go perpendicular on BC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. Then we extended the perpendicular from point O to BC towards AD. Okay, and because of the fact that side AD is parallel to side BC in rectangle ABCD, it means that the perpendicular from point O to BC must be also perpendicular to AD. Again, because of the fact that side AD is parallel to side BC in rectangle ABCD, the perpendicular from point O to BC must be also perpendicular to AD, because AD is parallel to BC. So this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral AT edge O, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of the fourth angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees, because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. So this angle must be equal to 90 degrees. So in quadrilateral AT edge O, we have 4 right angles. Therefore, quadrilateral AT edge O is a rectangle. Likewise, in quadrilateral edge ODM, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrilateral edge ODM, that has 4 right angles, it is a rectangle. Likewise, in quadrilateral TBON, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore, quadrilateral TBON is a rectangle. And finally, in quadrilateral ONMC, we have 1, 2, 3 right angles, and we have 1, 2, 3 right angles. Therefore, the fourth angle, this fourth angle must be also equal to 90 degrees, and therefore quadrilateral ONCM with 4 right angles is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Okay, then we define side AH as edge 1, we define side HD as edge 2, we define side AT as B1, and finally we defined side TB as B2. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle AT edge O, AT equals to edge O. But we know that AT equals to B1, therefore edge O must be also equal to B1. Likewise, AH must be equal to TO in rectangle ATHO, but we know that AH equals to H1, therefore TO must be also equal to H1. In rectangle AHO DM, we know that HO equals to DM, but we know that HO also equals to B1, therefore DM must be also equal to B1. Likewise, HD must be equal to OM, but we know that HD equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBON, TO must be equal to BN, but we know that TO equals to H1, therefore BN must be also equal to H1. In rectangle TBON, TB must be equal to ON, but we know that TB equals to B2, therefore ON must be also equal to B2. And finally, rectangle ONMC, OM must be equal to NC, but you know that OM equals to H2, therefore NC must be also equal to H2. And finally, ON must be equal to MC, rectangle ONMC, but we know that ON equals to B2, therefore MC must be also equal to B2. Then we join points A and O together by a straight line. In this way, we created the right green triangle ATO. In the right green triangle ATO, AO square equals to B1 square plus H1 square. I'll repeat again. In the right green triangle ATO, AO square equals to B1 square plus H1 square. Then we join points O and B together by a straight line. In the right yellow triangle TBO, BO square equals to B2 square plus H1 square. Repeat again. In the right yellow triangle TBO, BO square equals to B2 square plus H1 square. Then we join points C and O together by a straight line. In this way, we created the right orange triangle ONC. In the right orange triangle ONC, CO square equals to B2 square plus H2 square. In the right orange triangle ONC, CO square equals to B2 square plus H2 square. And finally, we join points D and O together by a straight line. In the right pink triangle DOH, DO square equals to H2 square plus B1 square. In the right pink triangle DOH, DO square equals to B1 square plus H2 square. So we have two different expressions for AO square, two different equations for BO square, two different equations for CO square, and two different equations for DO square. Therefore, we created equation number 1 that states that AO square according to equation number 1 must be equal to AO square according to equation number 2. That is to say, R square plus 35 square equals to B1 square plus H1 square. Then we created equation number 2 that states that BO square according to equation number 1 must be equal to BO square according to equation number 2. That is to say, R square plus 85 that is to say, here we have R square plus 85 square equals to B2 square plus H1 square. We created equation number 3 that states that CO square according to equation number 1 must be equal to CO square according to equation number 2. That is to say, R square plus H square equals to B2 square plus H2 square. And finally, we created equation number 4 that states that DO square according to this equation, equation number 1 must be equal to DO square according to this equation, equation number 2. That is to say, R square plus 35 square equals to B1 square plus H2 square. So we created 4 new equations here. Then we subtracted equation number 1 from equation number 2. That is to say, 2 minus 1. So in this side of equation number 2, we have R square plus 85 square. Minus, in this side of equation number 1, we have minus R square plus 33 square. And it is equal to, in this side of equation number 2, we have B2 square plus H1 square, minus equation number 1 that we have here, B1 square plus H1 square. Then we open the brackets of this equation, equation number 5, and we found out that R square plus 85 square minus R square minus 33 square equals to B2 square plus H1 square minus B1 square minus H1 square. So here we have R square minus R square in the side of equation number 5 that is 0, so R square will get cancelled. In the other side of equation number 5 we have H1 square plus H1 square that is also 0, so H1 square also will get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left is, in this side of equation number 5 we have 85 square minus 33 square. In the other side of equation number 5, we have B2 square minus B1 square. So according to equation number 5, we found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we subtract the equation number 3 from equation number 4. That is to say 4 minus 3. So in equation number 4 we have here r square plus 35 square minus equation number 3 we have in equation number 3. So it is minus r square plus x square. On the other side of equation number 4 we have b1 square plus h2 square. Minus this side of equation number 3 that we have b2 square plus h2 square. Then you open the brackets of this equation number 6 and found out that r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0, so r square will get cancelled. h2 square minus h2 square is also 0, so h2 square will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? On this side of the equation number 6 we have 35 square minus x square. And the other side of equation number 6 we left only with b1 square minus b2 square. Then we multiply this equation number 6 by minus 1. And found out that according to equation number 6, minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, minus b2 squared times minus 1 is plus b2 squared, and b1 squared times minus 1 is minus b1 squared. So in conclusion, we found out that x squared, according to equation number 6, x squared minus 35 squared equals to b2 squared minus b1 squared. And according to equation number 5, we found out that 85 square minus 33 square equals to b2 square minus b1 square. Then we created equation number 7 that says that b2 square minus b1 square, according to this equation number 5 must be equal to b2 square minus b1 square, according to this equation number 6. Here, this equation, b2 square minus b1 square, according to equation number 5 equals to 85 square minus 33 square, and it must be equal to b2 square minus b1 square according to equation number 6, that is equal to x square minus 35 square. So in conclusion, according to equation number 7, we found out that 85 square minus 33 square equals to x square minus 35 square. So we added 35 square to this equation number 7, we found out that 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225. 35 square is 1225 minus 33 square, that is 1089, that is equal to x square. 7,225 plus 1225 is 8,450 minus 8,008 minus 1081 equals to x square. 8,450 minus 1089 equals to 7,361. So in conclusion, we found out that according to equation number 7, x squared equals to 7,361. Then we took out all of this equation number 7, and found out that x equals to plus minus the square root of 7,361. So here we have two solutions that are possible for x, the positive square root of 7,361 and the negative square root of 7,361. But because of the fact that x is a length, x as a length must be a positive number, so we take into account only the positive solution. That is to say, x equals to 85.79x units. So we found out that the length of line segment x, the line segment that we are looking for, is equal to 85.796 units. We finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So in the domain we have a semicircle. We know that AB equals to 6 units. AB is the diameter of the semicircle that is equal to 6 units. Angle BAC equals to 30 degrees, and our mission is to find out the area of this green shape. So we define the center of this semicircle as O. We know that the diameter of the semicircle equals to 6 units, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 6 over 2, that is 3 units. So the radius OA equals to 3 units, and the radius OB also equals to 3 units. We join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point on the semicircle itself. Therefore, OC is the radius of the semicircle, that is equal to 3 units. So, in triangle AOC, OC equals to 3 units, AO equals to 3 units also, so those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, 30 degrees plus 30 degrees is 60 degrees, so the missing angle must be equal to 120 degrees. In order to complete the sum of the angles in triangle AOC to 180 degrees, this angle must be equal to 120 degrees. Then I presented to you the formula for the area of any sector. Sector is part of a circle, so here we have sector A or B, that could be any sector. AO equals to R, OB equals to R. They are both the radii of the semicircle that contains the sector. Theta is the angle between the legs of the sector. So AO and OB, they are from one side the radii of the semicircle that contains the sector. It could be semicircle or circle. And theta and AO and OB, they are also the legs of sector AOB. The angle between the legs of sector AOB is theta. So according to the new formula, the area of this sector AOB, equals to pi r squared, that is the area of the circle that contains the sector, times theta over 360 degrees. So I'll explain you what is the meaning of this formula. The ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle. And then when you will multiply this relative percentage by the area of the entire circle, that is pi r squared, you will get exactly the area of this sector. Again, when you will multiply the relative percentage that this sector occupies out of the entire circle, you will get exactly the area of this sector. Okay, the area of the entire circle is pi r squared. When you multiply it by the relative percentage that this sector occupies out of the area of the entire circle, so the relative percentage is theta over 360 degrees times the area of the entire circle, that is pi r squared, will give us exactly the area of this sector. Okay, so we use the new formula in order to find out the area of this sector AOC. So I copied sector AOC in this new page, and we implemented the new formula in order to find out the area of this sector AOC. AO equals to OC. They are both the legs of sector AOC, and they are also the radii of the semicircle. So this is equal to 3 units. And the angle between the legs of sector AOC, theta, equals to 120 degrees. So according to the new formula, the area of this sector AOC equals to pi r squared. R is 3, so pi r squared is pi 3 squared, times theta is 120 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. And 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3 square units. 9 over 3 is 3. So in total this expression equals to 3 pi. So in conclusion, we found out that the area of sector AOC equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. This is triangle ABC. It could be any triangle. The length of side AB is A units, side AC equals to B units in its length. And the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle ABC equals to A times B times sinus theta over 2. Use the new formula in order to find out the area of this triangle AOC. So this is triangle AOC, then the copy from the original drawing. AO equals to 4 units, OC equals to 4 units, and the angle between side AO and side OC is 120 degrees. So according to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. Okay, so AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. So in the numerator we have 3 times 3 is 9, so in total in the numerator we have 9 times square root of 3. In the denominator we have 2 times 2, that is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And we have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC equals exactly to the area of the green shape. So I repeat again, the area of the green shape according to the second method equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape according to the first method equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finished with the first method, and I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it is pi r square over 2. R is 3, so r square is 3 square, so in total this expression equals to pi 3 square over 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to do in order to find out the area of the green shape is to find out the area of sector COB. In order to find out the area of sector COB, we have to find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of AB at point O? We have this angle that is equal to 120 degrees plus the missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. So the missing angle here must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. So I copied sector COB in the new page and we implemented, we used the new formula in order to find out the area of the sector COB. This is sector COB that I copied from the original drawing. OB equals to OC, they are both the legs of sector COB, and they are both the area of the semicircle, that is equal to 3 units. The angle between the legs of sector COB is 60 degrees. So, and we know that the area of any sector is pi r squared times theta over 360 degrees. Okay, r is 3, so pi r squared is pi 3 squared. Theta is 60 degrees, so it is 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So in total this expression equals to 9 pi over 6. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2. So in total this expression equals to 3 pi over 2. So we found out that the area of sector COB equals to 3 pi over 2 square units. I remind you that according to the second method, the area of this grand shape equals to the area of the semicircle minus the area of triangle UC minus the area of sector COB. Repeat again, the area of the grand shape according to the second method equals to the area of the semicircle minus the area of triangle UC minus the area of sector COB. We have already found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AC equals to 9 times square root of 3 over 4 square units. And finally, we just right now found out that the area of sector COB equals to 3 pi over 2 square units. Okay, so 9 pi over 2 minus 3 pi over 2 equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So, in conclusion, we found out that the area of the grand shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay? Thank you very much.